Okay, let's take a look at detention time. All of these detention time problems are basically the same. And your detention time formula basically is going to be the volume of the tank, pond, digester, whatever it is, you need to calculate the volume. And typically you're going to calculate that volume in gallons. And then you're going to divide it by the flow. Volume divided by flow. But the important thing is here, you need to know what detention time they're asking for. So in our example problem here, they want the detention time in hours, which means that I have to convert flow into hours or gallons per hour in order to calculate the detention time. When I'm done making my conversions, I'm going to have a number in gallons over a number in gallons per hour, and when my gallons cancel out, I'm going to be left with a detention time in hours. So let's go ahead and do this. First, we're going to calculate our volume. Calculating volume, we have a tank that is 60 feet in diameter, 12 feet deep. So my preferred formula for calculating the surface area of a circle is pi times the radius squared. Radius in this case, if the diameter is 60 feet, is 30 feet. So my formula is going to be pi 3.14 times 30 feet times 30 feet. That would give us the surface area of our tank. And then to calculate volume, we need to add the depth, which is 12 feet. Hopefully my crude cartoon ability helps you to visualize that. And then I'm going to add one more step. Because I want this volume in gallons, I'm going to convert cubic feet to gallons. So if I really want to write this out completely, 3.14 times 30 feet times 30 feet times 12 feet times 7.48 gallons per cubic foot. So when I multiply that out, my cubic feet are going to cancel out, and I'm going to have a number in gallons. So let's go ahead and do that. 3.14 times 30 times 30 is 2,826 times 12 feet deep is 33,912 cubic feet times 7.48 gallons in a cubic foot gives me a total of 253,661.76 gallons, which I'm going to round up to 253,662 gallons. Next, I have to calculate my flow, 4.2 mgd. So 4,200,000 gallons per day. But I want to convert that to hours. So 24 hours. 4,200,000 divided by 24 is 175,000 gallons per hour. And now I'm ready for one more division problem, dividing volume in gallons by gallons per hour to get a detention time. So let's go ahead and do that. 253,662 gallons divided by 175,000 gallons per hour. My gallons are going to cancel out, and I get 1.4 hours. Now, all of the questions in your homework are pretty straightforward. I do want to make you aware of something just in case you might see it on an exam. And this is based on the concept that mostly for digesters, but also there is a little bit of a slope in round clarifiers or round settling tanks. The floor is not straight. It's going to be cone-shaped at the bottom, and that basically, because we're withdrawing sludge from the center, the floor is sloped downward from the sides to help facilitate that sludge moving. So you may see a problem where they give you the dimensions of the tank, but then they mention that, let's say the tank is 12 feet deep at the sidewalls and 14 feet deep in the middle. So that surface area is actually a little bit bigger. You have to account for the cone. So how do we do that? Well, the first thing we do is calculate the area of the cylinder, just like we did. And we would write that out. Pi times radius squared times the depth of the tank. Going to give us a volume in cubic feet. Now what about the cone? Well, here we go. We've got basically the same, the top of our cone has the same surface area as the top of the tank. So we can still use the same pi times the radius squared formula. We have 2 additional feet of depth, so we can multiply that by 2. But of course, this isn't a full cylinder, it's a cone shape. So we need to multiply pi times the radius squared times the depth times 1/3. The volume of a cone is going to be 1/3 of that if it were actually a full cylinder. So in this case, I would calculate volume in cubic feet of the cylinder part, and then I would add the volume of the cone, add them together to get a total volume. So I don't know how likely you are to see a problem that mentions that, but if you do, that's how you would do that. That's how you would think about it. And this actually might come into play in a practical application at our plant in Perrysburg. Occasionally we will use a settling tank to capture flow if we're trying to, say, divert flow from another part of the plant, and it's always good to calculate how long it will take for that tank to fill up so that we know how much time we might have to work with. But typically we don't account for the cone in the bottom because it's the slope of the floor in a clarifier is not all that great, so there isn't too much additional volume to account for, and then we just assume that it's canceled out by the mechanical equipment inside that clarifier taking up some space. So just wanted to point that out. You don't have any problems like that in your homework, so you wouldn't really have any opportunity to practice them. I just wanted to make you aware of how to think about that problem if it should ever come up. So, like I said, all detention time problems are pretty much the same. Calculate the volume of the tank or the digester or the pond, whatever. Calculate that in cubic feet, convert it to gallons, and then you have to convert your flow to gallons per whatever unit of time they want their detention time in. It may be days, it may be hours, it may be minutes, but you have to convert that flow to that unit of time. So don't forget to do that.